Hi everyone. We are starting a brand new topic. We're moving away from logs and we're getting into sequences and series. Today's lesson is going to be such a nice little review for you guys from Algebra 1. So if you look at your do now, we are talking about graphing the sequence. So let me just give you a little keyword here immediately. Sequence. Okay, a sequence is pretty much just a list of terms or elements. Okay, so when they tell you a sub n, that's how you say that, a sub n equals 2n plus 1, I know most of you are going to immediately know that that 2 represents your slope and that 1 represents your y-intercept. Okay, so a lot of people will say potentially choice 2 because you see a y-intercept at 1 and it's going up 2 over 1, up 2 over 1. What's the problem with number 2? You're connecting, okay? So just take note, your answer should be choice 1, okay? And the reason is a sequence, okay, which is what we're talking about here. A sequence should represent a list of terms or elements. Therefore, you should not connect the dots. Okay? It's only those specific numbers. It's not going to include every number in between. That's why we're not going to connect and make it a line. Okay, so let's keep going. A lot of this you guys are going to just remember. I'm not going to go through every little thing. It tells you definition of a sequence. It gives you all your little pieces of information like f of 1, f of 2, f of 3. They can call it a sub 1, a sub 2, a sub 3. Those are just the notation on how you talk about each term number in the sequence. So you guys can look over that. I'm going to go right into some of these questions. So in this one, they're talking about the shaded squares of each term. So when you start to go through and actually count the number that are shaded, in the first term, there's 12. The second term is 16, and in the fourth term is 20. So you may recognize these words, arithmetic versus geometric, from Algebra 1. This happens to be an arithmetic sequence, okay? And most of you are going to remember it's arithmetic because you are adding, okay? Adding 4 to get to the next term. That gives you what we call in arithmetic sequences a common difference, which they say D is equal to 4. Now, if you were subtracting by 4, if it went 12, then 8, then 4, then your common difference would be negative 4, and you would be subtracting 4. So know that an arithmetic sequence is going to be, when you are adding and subtracting, a constant number. So in this sequence, they're asking you to find a sub n. So best news I can give you is on your reference sheet, you will have both the arithmetic and the geometric formulas. On your reference sheet, you will see a sub n equals a sub 1 plus n minus 1 times d. Okay, and to ever get a basic formula for a sub n, which a sub n just means whatever term you are looking for. And these are called explicit formulas. Whatever term. So I could say, oh, we could find from this a sub n formula, we could find a sub 5, a sub 10, whatever I want. So in order to get a sub n, I plug in a sub 1. A sub 1 is my first term. Here's my first term, 12. Plus n minus 1. We don't know what n is going to be. That's why we're leaving it a sub n. And we're going to multiply it times d. D is our common difference, which here we said was 4. Now, if you notice in the choices, they're not there. But what we could do is simplify by distributing. So you'd get 12 plus 4n minus 4. And when you simplify your like terms, you get 4n plus 8, which is choice 2. Now, I want you to take note of the simplified version, 4n plus 8. Hopefully everybody notices this number 4. How does 4 relate back to the problem? Well, you'll notice, obviously I know most people will say it's the slope. It's also the common difference. Okay? Can anybody tell me how 8 relates back to your question? A lot of people sometimes will say, oh, it's the first term, it's the first term. It is not the first term. If you notice, your first term is 12. It's actually a sub 0. It's the term before term 1, which would be term 0, or a sub 0, which how would we get that? Well, if we know the first term is 12 and we keep adding by 4 to work backwards, we would just subtract 4, which would give us 8. So you're looking at your slope, your common difference, and your y-intercept. Your y-intercept is also your a sub 0. Okay. Let's take a look down at your next one. Number 2 is giving you another sequence. They tell you, okay, a sub 1 is 4, so your first term is 4. Your second term is 10. Your third term is 25. Your fourth term is 62.5, okay? And it's going to keep going. So I hope everybody realizes there's no number you could add or subtract at a constant rate to get to your next term. This cannot be arithmetic. This must be a geometric sequence, okay? This has to be geometric. Now, to get your common ratio, all you would have to do is take your next term and divide it by previous. It'll work every time. Next divided by the previous term. So, for instance, 10 divided by 4, you will get 2.5. If you do 25 divided by 10, you'll get 2.5. So it doesn't matter. You could do 62.5 divided by 25. You'll get 2.5. So your geometric sequence, okay, has what we call a common ratio instead of a common difference. And here that common ratio is 2.5. If you multiply 4 by 2.5, you get 10. 10 times 2.5, you get 25. So your geometric formula, which you will again see in your reference sheet, will be a sub n equals a sub 1 times your common ratio to the n minus 1 power. Notice it's in exponential form, where your arithmetic is in linear form. So when I plug in, again, a sub n could be anything, whatever term I want to look for. I would plug in my first term, which was 4, my common ratio, which is 2.5, and I raise it to the n minus 1 power. So that's going to be choice 4. Okay, and like I just spoke about, is the following pattern linear or exponential? In choice 2, this is exponential. Okay, it's exponential simply because it is not increasing at a constant rate. Okay, this is clearly, it's growing exponentially. Okay. So in the next slide, you guys, again, are just seeing a lot of notes, exactly what I just talked about. Just telling you about arithmetic sequences is where you're adding and subtracting. It has a common difference, and it's associated with a linear function. Where geometric sequences, you're multiplying technically or dividing, but even when you're multiplying and it's getting smaller, you're going to be multiplying by a fraction. You're going to have a common ratio, and it is going to be an exponential function, okay? So you see down here, your arithmetic and your geometric explicit formulas, which is what we just talked about right there. Your a sub n is going to get you any term you want in the sequence. A sub 1 will always be your first term. D is your common difference, and R is your common ratio, okay? So let's take a look at Maria. Maria's training for a triathlon. She is currently training for the bicycle portion, which is 25 miles of the race. She plans on biking. Okay, so here's some info. 3 miles on day 1, and she's going to increase by 2 miles per day. They want the explicit formula in simplest form. Your explicit formula is what we just talked about. These are your explicit formulas. So would this be arithmetic or geometric if it's increasing 2 miles each day? Well, hopefully you all realize if it's adding 2, this has to be arithmetic. Okay, and everybody's going to want to say arithmetic. That's fine, but that's what they call it. They call it the arithmetic versus geometric sequences. So if we use our arithmetic sequence, a sub n equals a sub 1 plus n minus 1 times d. We know that our a sub 1, which would be our day 1, was 3 miles. A sub 1 was 3. Plus n minus 1, and our common difference was that 2 miles per day. Now, if you gave an answer like this, it wouldn't be correct only in this question because it said simplest form. So when you distribute, you would have 3 plus 2n minus 2, and a sub n would be 2n plus 1. That would be your simplest form. Again, your 2 is representing your common difference, your slope, how it's increasing. Your 1 is representing, yes, your y-intercept, but also the 0 term. On day 0, they were obviously able to run 1 mile. Okay, so the next type of formulas that you may remember from A1 are what we call recursive formulas. And the weird thing about a recursive formula is that you can't get the next term until you have the previous term. So in explicit formulas, they're amazing. I could say to you, oh, find me the 99th term. All you would have to do is plug in 99 for n, and you could get me the 99th term. But in what we call recursive formulas, you can't get the next term until you have the previous term. Okay, so literally this is how it's written. It's a little bit confusing. Don't let it confuse you. When they say a sub n equals a sub n minus 1 minus 1. All this means is to get to the next term, this whole thing, a sub n minus 1, it just means take the previous term and subtract 1. Now, there's more than one way to write that. I could also say, oh, f of n equals f of n minus 1 minus 1. That means the same thing. To get to your next term, this would be the previous term minus 1. Now, they could also show you this way. A sub n plus 1 equals a sub n minus 1. This still means the term after. To get to the next term, this would be your previous term minus 1. They all mean the exact same thing. Okay? So I like to use, I think about consecutive integers. Remember when you guys did consecutive integers? You would say, okay, if x is any number in the whole wide world, 5, and I want the next consecutive integer, I know you would all tell me I would take x and add 1, right? Okay, so think about this. If this were the next term, what would be the previous term? The previous term would be x minus 1. That's all they mean when you see this a sub n minus 1 or f of n minus 1. It's the previous term. But let's say, I need a new color. Let's say this was the next term, x plus 1. Then this would be noted as the previous term. So that's what they're showing you when you see it this way. Oh, a sub n is the previous, and a sub n plus 1 is the next. So hopefully everybody is understanding that. So They're asking you to write a recursive formula for Maria's training plan. So let's just go back to Maria's training. Maria trains, and she always, it says on day 1, she had 3 miles, and she's increasing by 2 miles per day. So it's funny, it's not noted here, but in recursive formulas, you are to always state the first term. So the first thing I would write for a recursive would be a sub 1 is 3. And then if I want to write a recursive, I would say, a sub n equals the previous term, a sub n minus 1. What would I do to the previous term to get the next term? I would just add 2. That would be a perfectly acceptable answer. To get to my next term, I'm just going to take the previous term and add 2. Now, how else could somebody write that and be perfectly correct? Somebody could write, f of 1 is 3. First term is 3. And to get to the next term, f of n, I would take f of n minus 1, which is the previous, and add 2. That's one way to write it. The crazy thing is I could write it another way. I could also write, a sub 1 is equal to 3. That just means my first term is 3. I could say a sub n plus 1 equals a sub n plus 2. That means the exact same thing. To get to my next term, take my previous term and just add 2. So here's what you must understand. Let's say I want the 5th term in a recursive sequence. I can't get the 5th term until I have the 4th term. I can't get the 4th term until I have the 3rd term. I can't get the 3rd term until I have the 2nd term. That's why they're always going to state your first term so that you could then progressively get to the next term. So let's try one. Everybody take a look at number 5. They are immediately telling you which recursively defined function has to be a recursive formula, which has a first term equal to 10. Okay, if the first term is 10, just take a look at number 1. Is your first term 10? Yes, first term is 10. Okay, so this is a possibility. Look at number 2. Is your first term 10? No, this says your first term is 4. This can't be your answer. Okay, this one has a first term of 10, so that's actually good, potentially. This one says my first term is also 4. No good. Get rid of it. So we're down to 1 and 3. Now it tells us that we have a common difference of 4. That means D equals 4. What does it mean to have a common difference? It means we're talking about an arithmetic sequence. It means we are adding 4 to get to the next term. Here, this sequence says to get to the next term, take the previous and add 4. That's exactly what we want. This has to be it. Okay? They're telling you to add 4. So let's just take a look at number 3. This does have the first term of 10, but this says to get to the next term, do 4 times the previous. This is multiplying by 4. That's not what we want. That would be geometric. So that can't be our answer. Our answer has to be choice 1. Okay, let's take a look at 6. We're getting there. This is a good one. So they're giving you a sequence, and they want the 4th term of the sequence, and it's defined by, now this is immediately, here's what you need to say to yourself. This is recursive, okay? They are telling you that the first term, a sub 1, this is 3x y to the 5th. This is your first term, okay? And then here's the rule. To get to your, this is what this means. To get to your next term, take 2x over y and multiply it by the previous term. All a sub n minus 1 means is the term before it. So the first term that I could potentially get is the second term. I can't immediately jump to the 4th term. until I have the third term. But I can't get the third term until I have the second term. Now, I can't get the second term until I have the first term, but I have the first term. So in order to get the second term, I'm going to take, here's what it tells me, 2x over y times your previous term. Your previous term is 3x y to the fifth. I'll put that over 1, and I'm going to multiply. A sub 2 would be 6x squared y to the fifth divided by y, right? Numerator times numerator, denominator times denominator. But that can be simplified even further. The y's can be divided out. Technically, there's a 1 up there in that denominator, and I could say 6x squared y to the fourth. There's term 2. So now I can get, I'm going to go new color, term 3. To get term 3, I'm going to once again take 2x over y, and I'm going to multiply it by the previous term. My previous term is no longer 3xy to the fifth. It's now 6x squared y to the fourth. I'm going to put it over 1 for me to simplify. And to get my a sub 3, I'm going to multiply 12x cubed y to the fourth divided by y. You're going to start to see your pattern. 12, I'm keeping my x cubed, and my y is going to decrease by 1. Does everybody see that? So if you notice, you're multiplying your coefficient by 2. You're taking 1 away from your x. You're adding 1 to your x, and you're taking 1 away from your y. So let's go. Now we can get our fourth term. To get our fourth term, we're taking that 2x over y and multiplying it by the previous. Your previous is 12x to the third, y to the third. Putting it over 1. So my a to the fourth will be 24x to the fourth, y cubed over y, which simplifies to 24x to the fourth, y squared. And that should be your answer. That's what they were looking for, which you see right here in number 3. Okay, I'm going to do one more with you. Okay, let's look at the sunflower. A sunflower is 3 inches tall at week 0, so be careful. A sub 0 is 3. It grows 2 inches per week. Okay, so what does that tell us if it grows 2 inches per week? We're talking about an arithmetic sequence, and our common difference is 2. Which functions can be used to determine the height f of n of this sunflower? Okay, so here's what we know. We know our a sub, okay, so this is a good one. We know that a sub 0 is 3, but we do know a sub 1 technically, because if we keep having to add 2 every time, a sub 1 is 5. So let's just check out choice 1. If I find in choice 1 our arithmetic sequence, which remember, f of n would be our first term, f of 1, plus, and this you don't have to memorize, it's going to be on your reference sheet, n minus 1 times d. So let's try this. F of n would be, f of 1 here would be 5. Sorry, I used a's before, but a sub 1, f of 1, same thing. Plus n minus 1 times here our common difference is 2. So you don't see that there, but can I potentially simplify it? Okay, let's see. F of n would be 5 plus 2n minus 2, which would simplify to 2n plus 3. And that is absolutely choice 1. 1 works. Okay, let's look at 2. Does 2 work? It's funny, you have 2n, but 3 times n minus 1, choice 2 doesn't make any sense. You shouldn't have a 2n plus another 3n minus 3. So I'm saying choice 2 would never simplify to what we need it to be. If you took f of n and you did 2n plus 3 times n minus 1, that's telling you your common difference is 3, which it isn't. Your common difference is 2. This would give you 2n plus 3n minus 3, which totally makes no sense. Negative n minus 3 doesn't look good to me. Okay, look at your last one, choice 3. Choice 3, I want everybody to recognize as a recursive. Okay, it is not an explicit. Why? It's giving you, here it's not giving you your first term, it's giving you your 0 term. It's saying f of 0 is equal to 3. Is that true? Yes. And then it's telling you f of n equals f of n minus 1 plus 2. Okay, what does that mean? It means to get to your next term, take your previous term and add 2. Is that true? Do you keep adding 2 each week to get, yeah? You do keep adding 2. It's growing 2 inches per week. So choice 3 also makes sense. Okay, that one works. So you're looking for choices 1 and 3, which should be choice 4. Okay, that's the last one. So I'm going to stop there and I'm going to let you guys